Hi guys, so today I'm going to do Kickstart round A, and I won't lie, I'm under a lot of pressure because I'm heavily out of practice, and in the past I have performed really well in these contests, so I have a bar to maintain, and it's gonna start in a minute, so we'll be into that, and I am ready with my IDE. I have written this part so that like if I run the code, I have some multiple test cases, it will print this part, so I have that ready because that's needed in Kickstart rounds. And I'll be explaining the solutions after the contest. So this is just a screen record of me solving the contest. And yeah, make sure you also check out the link for the grand contest that is in the pinned comment. And make sure you register for that because that is also a very good contest and there are prizes for that as well. So do check it out. And I now just realized that I don't have pen paper. Okay, I'll manage. Okay, am I audible? Okay, hi. Yeah, so mm, like could have gone better, but I got well. Priyansh did really, really well. Rank 6. Wow. Mm, yeah, he was pretty fast here. So I guess I'm not gonna get any views for this one. Mm, okay, yeah. So I made a lot of silly mistakes, and that's why I have like a lot of penalties, and that's why I was slow as well. So yeah, but the problems were kind of good. The first one is just greedy. Yeah. So the in the first one, it's like let me do the solutions later. Okay, so time to do the solutions now. And regarding this round, I would say that while the problems, I wouldn't say that they were easy, they were fine, but they were very straightforward. It's like if you know the solution, you can come up with that very quickly, and like it's not very interesting or innovative kind of thing. So yeah, I felt that way. Like I don't think personally, I don't think this was a very good round. There was not a single problem in which I felt like, oh my god. So you can watch the solutions of all the problems, even if you don't understand them. You can watch all of them, and you'll kind of realize that it sounds too straightforward. There's no special intuition involved or anything like that. Yeah. First one is that you are given a string I, and you want to type that string I, and instead of typing I, you type another string P, and you want to delete some of the characters from P and get I. So for example, like if I wanted string A B C D, and instead of that, if I wrote A E B X C D, something like this, so what I can do is I can erase some of the extra characters and get the string that I wanted. So they are asking you how many characters do you need to remove, and whether it is possible to get the string back. So if it is possible, then definitely we know how many characters we have to remove. It's just the difference between these lengths. So the length here is 6 and the length here is 4. And if it is possible, then definitely we have to remove 6 minus 4 equals 2 characters. So that is obvious, but we have to check whether it is possible or not. So how will we check whether it is possible or not? So for that, we have to greedily connect these characters, like this A matches with this A, this B matches with this B, this C matches with this C, and D matches with this D. So for this, you can use a two pointer kind of approach in which you have a pointer at the beginning of each string. So we have a pointer at the beginning of each string. If these two characters are same, then you advance both of the pointers. And if these characters are not same, then you just advance the second pointer. Then again, if both are same, advance both pointers. If they are not same, then advance only this, and so on. So in this way, if you can reach the end of the first string, that means this entire string got matched, like each character got matched by these characters in the correct sequence. So then it is possible, otherwise it is not possible. So here's my code for that. Yeah. So I have the string s and t. I take the size of the strings, and then I have two pointers I and j, and I will iterate using these pointers. I'll do the two pointer kind of approach. If the character set both of the pointers are same, then you increase both the pointers. Otherwise, you increase only the second pointer. And then if you manage to reach the, like if you couldn't reach the end of the first string, that means it is impossible. That means you didn't find all the characters in the given sequence. Otherwise, just print the difference between the lengths. So yeah, so this was again this was straightforward. Then let's see the second problem. This is also pretty straightforward. Like only a little bit of innovation only a little bit of creativity was involved. So it's like basically you are given an integer n, and um, you want to insert exactly one character, exactly one digit anywhere in the number, and you want it to be a multiple of 9. And as you can see that these numbers can be very very big, so you cannot input it as an integer, you have to input it as a string. And yeah, so we have to make it a multiple of 9. So one property about multiples of 9 is that the sum of digits is divisible by 9. So basically the sum of digits is divisible by 9. Yeah, exactly. So like if you have a number 81, we know that this is divisible by 9 because if we do 8 plus 1 we get 9. Then similarly if we have any number 1 2 3 5 1, something like this, uh, yeah, something like this. So let's say if we have this number, so we know that this is divisible by 9 because if we add all of the digits, we will get 6 plus 5, 11, 12, and 18. And we know that 18 is divisible by 9. So yeah, so in this way we can do this. So using this idea, what we can do is we can see the number that is given to us in the input. For example, this number, and this number is like 12121. Okay, when then we can add all of the digits. So when we add all the digits, we get 1 plus 2 3 plus 1 4 6 and 7. Okay, so we know that 7 is not divisible by 9, but to make it divisible by 9 we have to add 2 here. So if we add 2 here, we get divisible by 9. So that means 2 is the digit that we have to insert in the string. Yeah, so we have to insert 2 somewhere in the string. So this way we can very easily find out which number we have to insert into the string. And then once we find that out, after that it is quite easy, because like for example, let's get done with one case. So if we have to insert 0 somewhere, so it is always beneficial to put the 0 in the second position. So it doesn't matter what the number is, you will always put the 0 in the second position. Why? Because you cannot put the 0 in the first position, because that will end up because that way you will end up with a leading 0. You don't want that. And if you put the 0 somewhere towards the right, that is not beneficial, because numbers are smaller if the digits on the left are smaller. So you want to put the 0 as left as possible. So second position is the as left as possible. So that's why we always put the 0 in the second position. But what if we don't have this digit as 0? What if we have some other digit? So what will we do then? So then we will have to find a suitable place for that digit. So let's say if we have to insert the digit D somewhere in the number, and the number is like W, X, Y, Z. So where should we insert this? So basically we should insert this in a way such that we make the smallest number possible. So that is given in the problem. We have to construct the smallest number possible out of all the numbers that we can get. So we can put D anywhere, but we want the smallest number. So if we consider all the strings in which D is there, for example, DWXYZ, or WDXYZ, or WXGYZ, and so on. So we can have like a lot of such strings. We want the smallest of these. And since these are like compared lexicographically, that means the leftmost should be the smallest. So obviously if W is smaller than D, so all of these strings will definitely be smaller. Similarly, if X is smaller than D, then all of these strings will be definitely smaller than the this one. So basically, we have to find a place. We will keep going to the next place until we find a digit such that that digit is greater than D. So if that digit is greater than D and we put D there, so when we compare with all the other, yeah, like for example, when we compare these two, so since we know that X is greater than D, so definitely this number will be greater than this number, and all the other numbers that we have, they will also be greater than this number, because we have X here and we have D here, and since X is greater than D, so this will be smaller. So that's what we had to do. Yeah, so is it that one? Yeah. So first of all, I found the sum of the characters. Take it mod 9. So that is the digit that we have to fill here. And if that digit is 0, so then just print the first character, then print the 0 and then print the rest of the string. But if it is not 0, then what we will do is we will basically try to find a digit which is smaller than which is greater than d. And once we find that, we will print everything on the left of that. We will print the digit and then we will print everything on the right. So yeah, so that's that. You should try to write the code for this on your own once, and then you will properly understand what's going on. And then we have this palindrome free strings. Yeah, so this one actually uses DP, but it is like very straightforward. So in this one, what we have to do is we have a string s, and consisting of character, it is consisting of character 0, 1 and question mark. So what we can do is we can replace the question mark with either 0 or 1, and we have to find, is it possible to assign the question marks to either 0 or 1 such that the resulting string has no substrings of so that are palindrome of length 5 or more. So one thing that we need to know is that 5 or more basically means just 5 and 6. So if you have a palindrome of length, let's say 7. So palindrome of length 7 means that there are 7 characters such that if you reverse them, that's the same thing. So it's like A, B, C, D, E, A, B, C, D, C, B, A, something like this. So we know that this is a palindrome of length 7. But in every palindrome of length 7, you also have a palindrome of length 5. And then same goes for palindromes of length 9. In 9 also you have a 7, and in 7 you have a 5. So any odd palindrome of length greater than 5 is will also have a odd palindrome of length 5. And apart from that, we also need to consider the palindromes of length 6, right? Because they can be like 8 will reduce to 6, 8, 10, 12, all of those will have a palindrome of length 6 in the center, and lengths like 5, 7, 9, 13, 17, 21, they all will have a palindrome of length 5 in the center. So we just have to avoid palindromes of length exactly 5 and we have to avoid palindromes of length exactly 5 and 6. So for this, what we will do is we will just use DP, and in this DP, like we have this string like this, 100 question mark question mark question mark 001, something like this. So what we will do is we will just move from left to right, and whenever we find a question mark, we will either try to put a 0 here or we will try to put a 1 here, and so on. So normally what we do in DP, we have two choices. We will try both of them. And what is the state, like what is all the information that we're storing? This is just the previous 5 characters we need to store. Previous 5 or 6 characters we just need to store. Like if you store the last 5 characters and we know this current character, so using this we get the string of length 6. So inside that we can make sure that that is not palindrome, and then from that we can take the last 5 of these and we can make sure that that is not palindrome. So that's all we have to do, and the implementation might be tricky depending upon how you do it. The way I did it, I actually got a wrong answer. I'm not very sure what I did here wrong. What I did here that was wrong. Maybe they should have been 34 or something. I'm not very sure. But yeah, so that's why due to due to implementation, I got one penalty here, and I wasted 7 minutes as well. So in total, it is what 12 minutes or something were wasted because of this penalty. So yeah, there must be some easier way to implement this, but yeah, the idea is just this, that keep putting 0 or 1 instead of all question marks, and then store the last 5, keep track of the last 5 characters that you have filled or that were already there. So yeah, so I won't show you the code because the way I did it is, I think, maybe not that straightforward. There must be some easier way to do it. But basically, I just kept the string of the previous characters and I convert that string into a binary number, and then I use that binary number to store in the DP array. So yeah, must be some easier way to do this, but yeah. And then this is the last problem. This was also not easy, but very straightforward. Again, due to some small implementation, like my array size was not big enough, so that's why I got another penalty here. But yeah, so this one is also not that tough. I mean, it's not easy, but it is like not very like you don't have to think of much intuition, not much creativity involved. It is very straightforward again. So a number is called interesting if if the product of digits is divisible by the sum of digits, and you have to find the number of interesting integers between a and b. Yeah. So you have to find the number of interesting integers between a and b. So a and b are given, and the range for a and b are up to 10 to the power 12. Okay. So normally what we do in these problems, the first intuition is very straightforward, is that you find the number of interesting integers from 1 to b, and you find from 1 to a minus 1, and you subtract them. So what we will do is, instead of taking the that thing, we will just do answer for b comma 1 minus answer of a minus 1 comma 1. Okay, so this makes it easier. We just have to care about one number at a time. So now all we need to do is focus on how to find the answer for b, answer for range 1 till b. So this we have to find now. Yeah, we have to find the number of interesting integers in this range. So interesting integers basically have this thing that they have the sum of digits and the product of digits same. So one thing we can observe here is that since these numbers are not very big, the the sum of the digits cannot be too much. So we know that there cannot be like more than 12 digits in this number. And even if all of them are 9, so you'll get something like 12 into 9, or uh, in fact, like 12 into 9 is the largest sum of digit that you can get uh, this way. So basically, we have 12 into 9, that is 108 or something. Yeah. So you cannot have your sum of digits greater than 108. And this is a good thing. So now what we can do is we can iterate on all the sum of digits, like from 1 till 108. And we will solve this problem for each sum of digits separately. So now what we want to do is, if we fix a sum of digit, let's call it SOD. So for this, we want the number of numbers in range 1 till b such that the sum of digits is equal to SOD, and um, the product of digits is a multiple of SOD. So yeah, so that's what we want. And we will use like a very famous technique for this, that is called digit DP. In digit DP, it's a very well-known technique. You can just Google it and find a lot of articles about this. So in digit DP, what we do is we just try to uh, fill a number digit by digit. Like let's say whatever number we have, whatever B we have. So B, for example, let's take something from here, 460. Yeah. So we will try to fill a sequence of 3 digits, and then we will try to make sure that this doesn't exceed 460. For that, we can do something like we put, like we know that we can put a 3 here, but we cannot put a 5 here. We can put a 4 here, but we cannot put a 5 here. So this kind of things we have to make sure. And then one by one, when we move from left to right, we can place the digits one by one. And the state information that we store has to be the position that we are at. That is obvious. We need to know the position. And then we need to know whether the number has started yet or not. So if we are having some leading zeros, that means the number hasn't even started. So we need to store that. And then we need to store whether the number has already become smaller or not. So for example, if we put a 4 here, so that means the rest of the number has to be smaller than this 60. But if we put something smaller here, let's say if we put a 2 here, so we can put anything here. We can put even 99 here, right? So we have to store whether the number has already become smaller, whether the number has started, which position we're at, and we have to store the remaining sum of digit. So at the beginning, we will give it a sum of digits, and then as we keep on putting digits, we will keep on decreasing that sum of digits. So we will need to store that, the remaining sum of digits, and we will also need to store the something which will help us realize whether the number is divisible by the sum of digits or not. So yeah, so that's why I had stored like a lot of state of information. So we have the position, Then we have whether the number has started or not, whether the number has become smaller or not, the remaining sum of digits, and also another value which will help us figure out whether this is divisible by sum of digits or not. So for this val, what I did is I just passed sum of digits in the beginning, and I want my number to be a multiple of this, right? So this is a number. The val is basically the number which is initially equal to the sum of digits. This is a number, and all the digits that I fill, the product of them should be a multiple of this. For example, let's say this is wait a second, yeah. So let's say this is 36, right? So I want that whatever digits I fill in, they should be a multiple of 36. So for example, let's say the digits that I'm filling, what if the first digit that I fill is 2? So then out of this 36, I can remove this 2 and get a 18 instead. And now I can say that in the remaining digits, I want the product to be a multiple of 18. And then if in the next place, if I put a 6, so then I can say that instead of 18, I want for these next two digits to be, the product should be equal to, it should be a product of 3. And then if I put like a 5 here, so since this 5 will not help with this 3, so still we have 3 remaining, and then we'll have to put a 3 or 6 or 9 here to get that thing. Yeah, so that's the only thing that we had to do. I mean, this is not only, but yeah. So basically, iterate on all the possible sum of digits. For each sum of digit, we will call dp of, we will call like, we want the dp of 0 position. Basically, the dp, I'll tell the dp states. So here we have position. Then we need to know whether the number has started or not, whether the number is smaller or not, what is the value, whose product we want the product of digits to be, whose multiple we want the product of digits to be, and the remaining sum of digits. So these are the 5 informations that you need to store, and the rest of it is very much, if you know digit dp, you'll know what these things are. This is quite obvious, but I'll tell you the main thing that we're doing. So yeah, so the main thing is that if we put a digit d here, so we will make sure that this value, this new value will become value divided by the GCD of d comma value. So what does that mean? So again, remember I said that we have to put like a 36 here. Let's say instead of 36, it is 12, right? And I have some digits. So what if I put a 9 here? So 12 is not divisible by 9, but like 3 will be removed from here, right? So this 12 will become 4. So what have we done to 12? So we have done 12, we remove 12 and we put 12 divided by GCD of 9 comma 12 instead. So this gives us 12 by 3 equals 4. So, yeah, so that's the main step, and that's the main thing that you have to keep in mind. So that's that way you put the new value, and then the sum of digits will get decreased by d. And you also have to make sure that whether if the number is not started, then you will not change this thing, and so on. So these are like some of the implementation details, and even I got stuck in these for quite some time. And another mistake that I was making was I was having this loop also with the I loop, and here also I have the variable I. So like it was very clumsy, and that's why I was getting errors for a long time. So yeah, and ultimately it turns out that this array size was not enough. So that's why I got another runtime error. So yeah, in silly mistakes, I wasted a lot of time, but my final rank turned out to be, I guess, 25. Yeah, so 25 global rank and India rank 4, I guess. Yeah, so India rank 4 and 25 global. My college junior is above me, and I don't know who this guy is. My college junior is right below me as well. So yeah. Oh wow. Basically, wow, nice. Like the three of us are probably going to be an ICPC team, and we're like continuously here with the rank difference of 4 each. But yeah. So and this guy did really well. It's like very well. despite these two penalties, he was able to, like, he was very, very quick here. So yeah. Mm. I think I also could have done maybe this much, or at least this much, but um, like I did a lot of silly mistakes probably because I'm out of practice. So yeah, that's it for this video. And this, like I said this last year as well, that I'll cover all the Kickstart rounds, but I covered only 4. So this year also I'm saying I'll cover all the Kickstart rounds, but I guess at least 3 or 4 I'll cover. I don't know. And also make sure you register for the grand contest. So the link is in the pinned comment and also in the description. So make sure you register for that. That's going to be interesting. And thank you for watching. I'll see you next time.